So we're going to start with a little bit of review from some previous things that we've done. So we have the slope and y-intercept discussion board, where we had these three things. We had a context, a table, and a graph, and the goal was to find the rate of change, right? And the y-intercept, and then write the symbolic rule. That's what we were going for. Okay. In the first one here, right, we have a canoe rental service charges a $20 transportation fee, $30 an hour to rent the canoe. All right. So in this case, the $30 an hour, that is our rate of change, otherwise known as the slope. And then this $20, right, that is our start value. It means when starting off, before we've even paid the hourly rate, we're paying $20. Okay, so we're asking for coordinates, right? So the coordinates of the start value, or the y-intercept, going to be at 0, 20. Right? No money has been spent, or no hours have been spent. We're still paying $20. That's the start value. Our rate of change is 30. Right, for the slope. So the rule y equals 30x plus 20. Any questions on the first one? Okay. Number 2, we've got a table here. All right. And again, we're looking for rate of change and y-intercept. Rate of change is going to be easier to find on this one because I have essentially a series of points. Right. I have a change of +2. All right, for essentially what's our x variable. And every 2 I add, right, I'm going up 360. Right. So if for every 2 I go up 360, that means for every 1, we're increasing 180. Okay, so this here becomes the slope. Now, I don't know what the earnings are when I've sold 0 vacuums. I have to go backwards. Essentially think we're going backwards on the table by going back 2 and subtracting 360. That will land me at 0. 600 minus 360, right, should be 240. So this would be the coordinates of the y-intercept. It would be at 0, 240. then gives us the rule, y equals 180x plus 240. Okay. Any questions on the second one? Okay. All right, our last one here, using the graph. All right, it's a little easy to see our y-intercept because it's just right here. Right, the y-intercept, that's going to be at the point 0, -2. Now our rate of change, right, we're going to look at the change in y divided by the change in x. So we can just use a couple of points. Doesn't matter which points we're looking at. Okay, I'm going to use ones that are easy to see. So I'll use this x-intercept and the y-intercept. Right, to get there, I go down 2 in y and plus 4 in x. We have -2 divided by 4. We get -1/2 as the slope. Right, so every 1 I go to the right, I go down 2. One sec. Sorry. For every 1 I go down, I go over 2. 1 down over 2. All right, so then we have enough for our rule now. I equals -1/2 x minus 2. Right, so using each of these three representations, a context, a table, and a graph, we can find the slope, y-intercept, and then find the rule. Okay, because all I need to write the rule is the slope and y-intercept. I don't need any other information. Any questions? No? Okay. Does anyone need a minute to write anything down? All right, something else that was mentioned by someone who's already done the self-assessment. So they'd like to see some examples or more examples of how to find your slope and y-intercept when you're only provided 2 points. So I've got a couple examples for this. So we're going to look at these. All right. Now, there's a formula for finding the slope when given 2 points that we can use. All right, and that formula looks like this: y2 minus y1 divided by x2 minus x1. All right, this is slope. And what this means is you take the second y-coordinate of the 2 points and subtract the first y-coordinate to get a number on the top, and then you take the second x-coordinate, subtract the first x-coordinate to get your number on the bottom. You do the division, and that gives you your slope. So in this example, right, this would be x1, x2, y1, y2. So for slope, we're going to get 7 minus 3 divided by 2 minus 1. Because it's 4 divided by 1, which equals 4. So that's our slope. Right. Now we need to solve for the y-intercept, or for b, right? The value of y when x equals 0. And to do that, all we do is pick one of our 2 points, a or b, and put it into the form of the rule. Right. Our general form is y equals mx plus b. We already found m. We need to find b. So what we do is say we pick point A. And so we replace y with 3. We have a slope of 4. Replace x with 1. And write b as the variable. And we get 3 equals 4 plus b. We will subtract 4 from each side. 3 minus 4 is negative 1. So negative 1 equals b. That leaves the rule to be y equals 4x minus 1. So we can find the rule if all we're provided is just 2 points, 2 coordinates. We can go through the same process here for number 2. We have m equals negative 10 minus 6 divided by 3 minus negative 4. Negative 10 minus 6 is negative 16. 3 minus negative 4 turns into 3 plus 4. So that's 7. This is a horrible fraction. I made these numbers up. Negative 16 of 7. It's going to be, we can write this as an improper fraction. It's negative 2 2/7. All right. Writing it as a proper fraction here is negative 2 2/7 is fine. The fraction itself is a little more useful as far as graphing is concerned. We can also just write it as the decimal in this case as well. 2.29. Okay, so I mean, you're asking, wait, on number 1, why did I do 3 equals 4 times 1 plus b? So I'm replacing, this is 3 is the y coordinate from point A, right? So the 3 went in place of y, and the 1 replaces x in the general form of the rule, right, where we have y and x. So I take the x and y coordinate from my point, or one of the 2 points, doesn't matter which one I choose, I'll get the same result, so that then I can solve for b. All right, we'll see that again in this number 2 here. So we've got our slope. We have a few different representations for it. We'll use the decimal just to make it easier to write. And then let's use point B here to solve for B, or for the y-intercept. So we will use negative 10 equals, I'm going to use the fraction negative 16 over 7 times 3 plus b. All right, so we'll use we need to do the multiplication, the negative 16, 7, 3 first. Let's see. Okay, that doesn't do anything friendly. 7 is a prime number, so it doesn't usually divide very friendly. We will end up with negative 10 equals negative 48/7 plus b. Right, then we need to add the 48/7 to each side. Right, we'll cancel over here, negative 10 plus that number. Negative 3 1/7, or negative 22/7. This is about negative 3.14. So we end up with the completed rule that we can write as y equals negative 16 over 7x minus 22/7, or we could choose to write it with the decimals, negative 2.29x minus 3.14. Essentially, both are the same. If you want to get super technical, using the fraction is the more accurate of the two answers because you're not losing any accuracy. When you round a decimal, you will end up with an error over time. So your results might vary from someone else who's using the fraction form of the formula. All right. Any questions about this process? Okay. All right. So next, we're going to look at a couple of different contexts here, so that we can look at going from like a context to the representations and then to finally finding a solution, and what that solution looks like across the different contexts. So let's get started. We're going to kind of work these two problems kind of side by side here. So in our first context, we have Jim. He wants to start saving some of his money every week so he can buy a drone. He starts with $1 in his piggy bank and will add $3 every week. That's what he can afford to save. How many weeks will it take for Jim to save the $150 he needs for the drone? All right. So first thing, okay, let's just look at, we have a start with $1. We're going to add $3 every week. So we have a start value and we have a slope, essentially. So we can, from that, write the rule. All right, we have y equals 3x plus 1. Get our slope here, start value here. Right, we could say the y-intercept here is going to be at 0, 1. If we wanted to give the coordinates. Right. So that's what our rule looks like in this case. We can also write this as the all interesting now next rule. Now plus 3 equals next. Starting at 1. We have that as well. So we have that. We have our symbolic rule. We have our now next rule. We have our y-intercept there. So we can represent this rule or this situation with our rule here. We can also use a table to help show what's going on here. Right. We can do the first few numbers within our table here. We know we start at 1, we add 3, 4, 7, 10, 13, so on. This would just continue. Right. So now we have all these things we can do, right, for this situation. We can also look at a graph. In this case, it doesn't make sense to do the negative portions of our graph because we're talking about money and time. So we can have kind of this be the number of weeks. That's going to be money saved. Right, so our graph here isn't going to show enough for us to solve the equation, but we definitely have the line started. And we can use our table to start this graph. We start at 0, 1, 0, 1, 4. I'm going to go over 1 and up 3 more. That's enough to get started. So here's a graph. All right, we can see that this is kind of steep. There we go. We have our representations for this situation. So then we can use this now. We have a few different strategies in solving. All right. We can continue the table. Right. If we continued this table, right, and we just kept going and going and going, we would eventually get to our solution down here, way down here. All right, and what we see here is we don't actually land right on $150, right? At week 49, it's too low. We're at 148. We don't have enough, Jim doesn't have enough money yet. But at week 50, now he has enough money. Okay, so in this case, I don't necessarily need to hit 150 right on the number because it's just asking how many weeks. 49 is not enough, 50 is, right? So we can say the solution here in this case is 50 weeks, right? That answers the question being asked. our graph here, we're not going to be able to see the solution. Obviously, we're only going to we have 10 weeks on the x-axis, but only up to $10 on the y. We need a much larger graph, which we could look at if we went to Desmos, and we could do that process, put it in the Desmos, look at our graph, get it all the way up to 150 on the y-axis, find the coordinates, and see the solution there. That is an option. I'm not going to look at that right now. Our other possibility here is to actually solve the equation for the value of y that we want. Right? And so what that would look like would be in our rule where we have y equals 3x plus 1. We would change y for 150 because that's the value I want my equation to be equal to. So we would start it with 150 equals 3x plus 1, and then solve for x. Right. And we get the decimal 49.67 approximately. It is 49 2/3, which means it will take 50 weeks. 49 weeks, again, is not enough. So we end up with the same solution that it takes 50 weeks. All right. Any questions on this example? All right, so then we have our second example. The Department of Parks and Recreation in a small town is monitoring the height of the water in a lake. Currently, the water level is 2 feet below its highest level. Right? The water level is dropping at a projected rate of 1.5 feet annually. If this trend continues, in how many years will the lake be 20 feet below its former highest level? Right, so we have, again, in our context, where we have a start value and we have our rate of change. Right, 2 feet below, right, we're at a -2. Right, and the slope is also negative, right, because it is dropping. So this gives us a rule. -1.5x minus 2. And again, we can write this now -1.5 equals next. Starting at -2. As the other example, we can make a table. And again, because we are talking about time, it doesn't make sense to start with negative numbers for x because we don't have negative time. All right. So at 0, we're at -2. After 1 year, right, we're at -3.5, -5, -6.5, -8, and so on. All right. We could also look at a picture of the graph. And in this case, I'm drawing positive x and the negative y-axis, because that's what makes sense for this context. I'm going positive in time. But I'm going negative with the other direction in y, because this is the height of the water. Right? We start at -2. I'm going to go to 2 and -5, using the nice whole number ones, 4, -8. And that's going to give me enough to draw the line. All right. So we have all of our different representations for this context, and then again, we need to solve this. Right. Just as in the other example, I could continue this table, right, and just continue it going down, and I would get to the solution here, down here. And we hit a water level that's 20 feet below the highest level, right, at 12 years. And again, the graph could be used in the same way. We would need a little bit more of the graph, and we need to draw it a little bit more accurately than by freehand. We'd want to use like graph paper and such, or use Desmos, right? And we would be able to go to 12 years here, or start at 20, -20 down here somewhere, and follow it over, and we would cross the line at 12. Right? And we can also use the same kind of method as we did in the other problem, where we can solve this algebraically by setting y equal to -20. Started at -2. Right? And then we solve for x. And this will give us 12 equals x. So again, we get the same solution. All right. What questions do you have? No question? Okay. All right. So then, let's look at Canvas. All right, we are in week 10. All right, it is Wednesday. We're on our live session. We have a discussion board for after class today. You're provided a graph and a table. This is a table that's been chopped in half, and one half is on the left and one half is on the right. It is the same table. You could stack them and it would read a little easier, but that's just not the way it was provided. We have our two equations. Y1 is 98 minus 0.54t. Y2 is 2 plus 0.54t. These equations represent the trend in male and female doctors since 1960. We have our graph over here to the left. And your task in this discussion board is to find the solutions to these 5 equations by either using the graph, the table, or algebra. Whatever method you want to use is up to you. You need to find the solutions.